Hi and welcome to E-ZTutoring. Today we're going to cover how to graph rational expressions. Now, I have a rational expression written down over here, and whenever you go about graphing one of these, it is very important to have a checklist, to have a number of steps. Now, I went ahead and wrote one down here. Now, we're just going to focus on the first step for now. We have to find our intercepts, as in our x-intercepts and our y-intercepts. So let's start with an x-intercept. In order to find an x-intercept, you must plug in 0 for y. If you guys remember what x-intercepts are, pretend this is the x-axis. It's anywhere where the graph crosses the x-axis. And anywhere where the graph crosses the x-axis, your y is 0. So we go ahead and plug in 0 for y. We get x plus 2 over x squared minus x minus 6. Now, as you're finding your x-intercept, I highly recommend simplifying your graph. Now, here's why. X squared minus x minus 6 actually simplifies into x plus 2 times x minus 3. The reason you want to simplify your graph is because you may end up getting an x-intercept that is not allowed because of what's in your denominator. That's actually what's happening in this case, because x plus 2 we can cross out, and we have to cross them out. So now we get 1 over x minus 3. So when finding your x-intercept, you plug in a 0 for y, and you want to see what x must be equal to make that true. Now, of course, your denominator can never be 0, so you don't even want to worry about the denominator. You can actually multiply to get rid of it on both sides. You only want to worry about your numerator and just set your numerator equal to 0. Now, in this case, we got 0 equals 1, which is not true, which means there are no x-intercepts on this graph. I feel I should talk a little bit more about this. What you can do is you can just start from the beginning with your function and just right off the bat take the numerator and set it equal to 0. But of course you would have to go from this step once it's already simplified, because what would happen if you took this and set it equal to 0? You would get that x equals -2, right? But here's why that is so wrong. Because if you take x equals -2 and plug it in the denominator, you'll get 0 in your denominator, which is a big no-no in math. You do not want zeros in denominators. That is an undefined number. Even if you get 0 over 0, that is still undefined. So x cannot equal -2 or 3, because that would make the denominator 0. So if we had something else in the numerator, then yes, we would have an x-intercept, but in this case, we do not. Now, let's talk about y-intercepts. In order to find your y-intercepts, what you do is you plug in a 0 for x, because wherever it crosses the y-axis, your x is 0. So f of x equals 0 plus 2, because we're plugging in 0 for all the x's, over 0 squared minus 0 minus 6. This is 2 over -6, which is -1/3. Now, you should write this as a coordinate. You should not leave it as just a number. So this is going to be 0, comma, -1 over 3. How do you know whether to put the 0 here or here? Well, this is a y-intercept, so it's like saying y equals -1/3, and this is the y coordinate. So I will go ahead and save this over here as valuable information. Can you guys see that? No, that is too high. Okay, on to step number 2. We want to find our vertical asymptote and our holes, if any. So vertical asymptote is a dashed vertical line which shows that your graph can never ever pass through. So that means that there are no x values that will exist over there. How do you find those x values? Well, in a function like this, what value are we never allowed to have? Something over 0, right? So what we want to do is we want to find the numbers that make the denominator 0. So we go ahead and factor that once again. Now, before we jump into this step, it is important to cross out whatever you have in common once again. It is important to simplify your function before this step as well. So, now that we went ahead and simplified it, we can take the denominator and set it equal to 0. So we take this, x minus 3, and set that equal to 0, and we simply get that x equals 3. This is your vertical asymptote. Now this works because when you plug in a 3 into the denominator, you get 1 over 0, which does not exist. That does not work. So x equals 3 is a vertical asymptote. Now why do we have to cross these out? Why isn't x equals negative 2 a vertical asymptote? Well, whenever you can cross out something in your denominator with your numerator, that is where holes come into play. So x plus 2 has to do with one of our holes. So we take x plus 2 and we set it equal to 0. And we solve for x, and we get that x equals negative 2 is a hole. So holes and vertical asymptotes, they are similar. You find them the same way, but there is something unique that distinguishes holes. What makes a hole a hole? If you plug in a negative 2 in this function, you get 0 over 0. Versus plugging in a 3 into this function, you'll get 5 over 0. So whenever you get 0 over 0, that creates a hole. So I will go ahead and write this down as valuable information, and we'll go on to step number 3. So on to step number 3, we need to find our horizontal asymptote. It is the same exact thing as a vertical asymptote, except that it's horizontal. So in order to find this, there are actually a number of rules that you need to know. There are 3 rules. And these rules go by the highest degree in the numerator and the highest degree in the denominator. So you need to figure this out before you start attempting number 3. You can do it with this simplified or not simplified. It does not make a difference. The highest degree in the denominator is 2. And the highest degree in the numerator is 1. So whenever the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is y equals 0. Now, this is true for this problem. Our horizontal asymptote really is y equals 0. So, there are other cases that I do need to cover. Say in the case that your numerator, the degree of your numerator is equal to the degree of your denominator. In that case, your horizontal asymptote will be equal to your first coefficient over your second coefficient. What does that mean? You take the coefficient in front of the x's with the highest degree. So in this case, you take this coefficient, which is 1, and this coefficient, which is 1. And you do the top coefficient over the bottom coefficient, and you get that y equals 1 is your horizontal asymptote if this is true. In this case, that is not true. But for other problems where it is true, I would like you guys to know this rule. Now, your very last rule is your degree of your numerator is greater than your degree of your denominator. in that case you will have what's called a slant asymptote. Your asymptote will not be horizontal, it will actually be slanted. So in order to find that, what you do is you actually divide your numerator by your denominator. So what you do is you actually set up your division here, and you get x plus 2 will be divided into x squared minus x minus 6. And well, you work all this out and you will get something for your y, and that would be your slant asymptote. So those are all the rules for step number 3. Now we can start graphing. So when we start graphing a function like this, we go ahead and we graph our valuable information first. Now all that valuable information is everything we found over here. So we can go ahead and we can label the y-intercept. I should have probably written that this is y-intercept. So that is a 0, negative 1 over 3. That is going to be right over there. And I label it in blue so we can match the colors. Our next thing that we found was x equals negative 2 is a whole. Now, when labeling that, it's kind of tricky because when we plug in x equals negative 2, we don't exactly know where that point is on the graph because we get 0 over 0. So I'm going to wait to plug in the whole. I'll do that last. If you'd like to do it now, you can plug it into the simplified form and do that, but that's extra work. So x equals 3 is your vertical asymptote. So 1, 2, 3, and you count on the x-axis since it's your vertical asymptote, and you get a vertical dashed line of x equals 3, which means your graph can never, ever, ever touch this line. Y equals 0 is our horizontal asymptote. So of course we count on the y-axis now, and 0 is here. So our horizontal asymptote is really the same as the x-axis. So I make a dashed line over here, and well, this is our horizontal asymptote, y equals 0. So we went ahead and labeled everything except the wholes. So now by looking at this graph, on the left side, we have a point here. So because we have that point, what should I label this graph in? I'll make the graph in orange. Because we have this point, we can guess, and a very accurate guess, not guess, we know what happens to the right of the graph. Towards the right, this obviously cannot go up because of the horizontal asymptote. It cannot cross through that asymptote, so it can't go up, and then it must go down. Now, of course, it cannot go past the vertical asymptote because it's not allowed. That's why we have an asymptote. So therefore, it must go down like this forever. That is the only possible thing that it can do. So now we can also label our whole. Our whole was at x equals negative 2, right? Over here. And towards the left, it must go up. And the reason for that is because since it was going down over here and it's slowly starting to rise, then it must go up. You can test that by plugging in points, or you can take my word for it. You do take my word for it, and you do know that it goes up, then your whole must be just a little bit higher than that point, so your whole must be around there at x equals negative 2. So then you just connect the dots with your graph, and of course it can never actually cross your horizontal asymptote, but it'll get very close. Now, what does it do on the right side of the graph? Does it go like this? Does it go like that? Does it go like that? We won't know till we plug in points. So we make an x, y table, and we should plug in points past the vertical asymptote. So we have 1, 2, 3, 4. 4 is the first point past the vertical asymptote that is the point we should plug in for x. When you plug in 4, you will get a 1. I won't go through the algebra because we'll be here all day, and I'm sure you guys want to get rid of me pretty quickly. So we have 4 comma 1, which goes right there. We could plug in a 5 and get 1/2, which will go right there. So we can see what this graph is doing. We know it does not cross the horizontal asymptote, right? So because it doesn't cross that asymptote, therefore, it must go like this on forever and ever. It'll get infinitely close to that asymptote, but never touch or cross it. Now towards the left, you can see that it's slowly rising. And of course, it does not pass this asymptote, so therefore, it must also get very, very close to this asymptote. And what you see in orange, I don't know if the colors are that clear, but that is going to be your graph for the rational expression I gave earlier. I know it seems like a lot, and I know this may be overwhelming, but really all it is just following steps. As long as you follow these steps every time, you'll be able to graph any rational expression. So I hope I helped you guys out. For ACT or SAT help, be sure to visit my website, www.e-ztutoring.com. Thank you guys, and good luck.